Physics is all about studying our universe. It's a field that seeks to understand the fundamental principles that govern everything around us, from the smallest particles that make up matter to the vast galaxies that stretch across the cosmos. Physics aims to uncover the mysteries of existence. It's a journey of discovery that has fascinated humans for centuries, pushing the boundaries of what we know and challenging our perceptions of reality. It tries to figure out the basic rules that control everything, the laws that dictate how particles interact, how forces work, and how energy flows. These rules are often expressed through complex mathematical equations, which might seem daunting at first glance, but these equations are the language of the universe, providing a framework that helps us make sense of the natural world. From tiny particles to massive galaxies, physics covers an incredible range of scales. On one end, we have the realm of quantum mechanics, dealing with particles so small that they defy our everyday understanding. On the other end, we have cosmology, which studies the universe as a whole, exploring its origins, structure, and ultimate fate. Modern physics, which started in the early 1900s, completely changed how we understand space. Pioneers like Albert Einstein and Niels Bohr introduced revolutionary ideas that challenged classical notions of space, time, and matter. Their work laid the foundation for new theories that have since become cornerstones of modern science. It introduced big ideas like quantum mechanics and relativity. Quantum mechanics reveals a world where particles can exist in multiple states at once, and where the act of observation can change the outcome of an experiment. Relativity, on the other hand, shows us that space and time are interconnected and that massive objects can warp the fabric of space-time itself. These theories are really different from what we see in everyday life. In our daily experiences, objects have definite positions and velocities, and time flows at a constant rate. But in the quantum world, particles can behave like waves, and events can be probabilistic rather than deterministic. It's a realm that defies intuition and requires a new way of thinking. They show us a universe that's much stranger and more amazing than we ever thought. The more we learn, the more we realize how much there is still to discover. Each new finding opens up more questions, driving the quest for knowledge ever forward. Modern physics isn't just a complicated idea, it's a practical science that has real-world applications. The principles of quantum mechanics and relativity have led to technological advancements that we use every day, often without even realizing it. It affects our lives every day. From the tiny parts in our phones to the lasers in our CD players, the technology we use is built on modern physics. These advancements have transformed the way we communicate, work, and entertain ourselves. From the tiny parts in our phones to the lasers in our CD players, the technology we use is built on modern physics. These advancements have transformed the way we communicate, work, and entertain ourselves. The technology we use is built on modern physics. It's a testament to human ingenuity and our ability to harness the laws of nature for practical purposes. Every device we use is a product of countless hours of research and experimentation, driven by a desire to understand and manipulate the physical world. This field shows how curious humans are. We always want to understand the universe better. This curiosity has led to some of the most profound discoveries in history, revealing the underlying principles that govern everything from the smallest particles to the largest structures in the cosmos. We always want to understand the universe better. This drive to explore and discover is a fundamental part of what makes us human. It's a journey that has no end, as each new discovery leads to more questions and deeper mysteries. This video will explore the exciting world of modern physics. We'll delve into the strange and fascinating concepts that have reshaped our understanding of the universe and see how these ideas are applied in the technology we use every day. We'll look at the weird world of quantum mechanics, figure out Einstein's relativity, and explore the mind-bending implications of these theories. We'll see how they challenge our perceptions and open up new possibilities for understanding the universe, and travel to the edge of the universe with cosmology. We'll explore the origins of the cosmos, the forces that shaped it, and the ultimate fate of everything we see around us. It's a journey that takes us from the smallest particles to the largest structures, revealing the interconnectedness of all things. Join me as we unlock the universe's secrets and discover the wonders inside. Together we'll embark on a journey of exploration and discovery, delving into the mysteries of the cosmos and uncovering the fundamental principles that govern our existence. Let's unlock the universe's secrets and marvel at the wonders that await us. In the early 1900s, physicists started looking closely at atoms. They found a world with completely different rules, quantum mechanics. This new physics showed a world where energy and other things aren't smooth but come in tiny chunks called quanta. Here, tiny bits of matter act like waves, and waves act like tiny bits of matter. This weird duality is the key to understanding quantum mechanics. One of the strangest parts of quantum mechanics is superposition. Imagine a coin spinning in the air. Not heads or tails, but both at the same time. That's like a quantum particle in superposition. It's in many states at once. Only when we look at it does it choose one state. Quantum mechanics also introduced entanglement. Two entangled particles, no matter how far apart, are connected in a weird way. Measuring one instantly tells us about the other, even if they're super far away. This spooky action at a distance, as Einstein called it, is still a mystery that physicists are studying today. One of the most interesting parts of quantum mechanics is wave-particle duality. This concept challenges our classical understanding of physics and forces us to rethink how we perceive the fundamental nature of light and matter. This means things like electrons and photons can act like both waves and particles. It's a duality that has puzzled scientists for decades and continues to be a topic of intense research and debate. We saw this in the double-slit experiment, a classic demonstration that reveals the dual nature of light. This experiment has been repeated countless times, each time confirming the strange behavior of light. Imagine shining light through two tiny slits. At first glance it seems like a simple setup, but the results are anything but straightforward. If light were only a wave, we'd see a pattern on a screen behind the slits made by the waves overlapping. And that's what happens. The light creates an interference pattern, a series of bright and dark bands indicating wave-like behavior. The light makes a pattern, even though it goes through two slits. This pattern is a hallmark of wave interference, showing that light can spread out and overlap just like water waves. This shows light acting like a wave. But the story doesn't end there. The wave nature of light is just one side of the coin. But if we make the light very dim, so only single photons go through, something amazing happens. Each photon seems to make its own decision about where to go. Each photon hits the screen at one spot, like a particle. This particle-like behavior is evident when we detect individual photons arriving at specific locations on the screen. Over time, these hits make the same wave pattern. Even though each photon acts like a particle, collectively they form an interference pattern, just like waves. Each photon goes through both slits, interferes with itself, and then hits the screen like a particle. This self-interference is a key feature of quantum mechanics, showing that particles can exhibit wave-like properties. This wave-particle duality is strange. It defies our everyday experiences and challenges our understanding of reality. How can something be both? This question has intrigued and perplexed scientists for over a century. The answer is in quantum mechanics. This branch of physics provides the framework to understand these dual behaviors. In the quantum world, particles don't have definite states until we measure them. They exist in a superposition of states described by a wave function. Instead, they're described by probabilities and wave functions that tell us how they'll act. These wave functions give us the likelihood of finding a particle in a particular state or location. Quantum mechanics also introduces the concept of entanglement, where particles become interconnected and the state of one instantly influences the state of another, no matter the distance between them. Another key principle is Heisenberg's uncertainty principle, which states that we cannot simultaneously know the exact position and momentum of a particle. This inherent uncertainty is a fundamental aspect of the quantum world. These principles are not just theoretical, they have practical applications. Quantum mechanics is the foundation of technologies like quantum computing, which promises to revolutionize how we process information. As we continue to explore the quantum realm, we uncover more about the nature of reality and the universe. The wave-particle duality of light is just one piece of this vast and intricate puzzle. The journey of understanding quantum mechanics is ongoing, with each discovery bringing us closer to unlocking the mysteries of the universe. The dual nature of light serves as a reminder of the complexity and wonder of the quantum world. Superposition and entanglement are two of the strangest ideas in quantum mechanics. These concepts challenge our classical understanding of the world and open up a realm of possibilities that seem almost magical. They are fundamental to the way we understand the quantum world and have profound implications for technology and our understanding of reality itself. They change how we think about the world and could lead to new technologies. Imagine a future where quantum computers solve problems that are currently impossible for classical computers, or where quantum communication ensures completely secure data transfer. These are not just theoretical ideas. They are actively being researched and developed in labs around the world. Superposition, as we talked about, is when a quantum system is in many states at once. This means that a particle can be in multiple positions or have multiple energies simultaneously. It's a bit like having a cat that is both alive and dead at the same time, a famous thought experiment known as Schrödinger's cat. Like a spinning coin that's not heads or tails until it lands. In the quantum world, particles exist in a state of probability until they are observed. This is a fundamental departure from classical physics, where objects have definite states. This is important for quantum computers. Quantum computers leverage superposition to perform many calculations simultaneously. This parallelism allows them to solve certain types of problems much faster than classical computers. It lets them do calculations on many values at once, making them much faster than regular computers for some tasks. For example, they could revolutionize fields like cryptography, optimization, and complex simulations, potentially solving problems that would take classical computers millions of years to crack. Entanglement is the weird connection between two or more quantum systems, even if they're far apart. When particles become entangled, their properties become linked in such a way that the state of one particle instantly influences the state of the other, no matter the distance between them. Imagine two coins flipping perfectly together, always landing on the same side, no matter how far apart they are. That's like entangled particles. They're linked. This phenomenon puzzled even Einstein, who famously referred to it as spooky action at a distance. The strange thing about entanglement is that measuring one particle instantly tells us about the other, no matter how far apart they are. This instantaneous connection seems to violate the principle that nothing can travel faster than the speed of light, leading to many debates and experiments to understand its implications. This spooky action at a distance, as Einstein called it, seems impossible. Yet it has been confirmed through numerous experiments. These experiments have shown that entangled particles do indeed exhibit this instantaneous connection, challenging our understanding of space and time. But entanglement has been proven many times. Scientists have conducted experiments that repeatedly confirm the predictions of quantum mechanics, demonstrating that entanglement is a real and measurable phenomenon. It's very important for quantum communication and cryptography. Entanglement can be used to create secure communication channels that are theoretically immune to eavesdropping. This could revolutionize the way we transmit sensitive information, making it possible to achieve unprecedented levels of security in our digital communications.